So machine learning, what do we do? So rather than getting into all the complexities of machine learning, I'm just going to give you a basic problem. Let's say I were to make a different type of music streaming company, and I wanted to recommend suggestions to what kind of music I like. So let's say, for example, there's only two things that matter when I like a particular song. So in this case, let's say it's the tempo and it's the volume. So let's express tempo as the y-axis here. And let's express loudness or volume as the x-axis. Now, let's say, for example, we collected a few songs that I've listened to and we rated whether or not I like them or I dislike them. And we placed them on the scale. So let's say, for example, I liked a song that was here. I liked a song that was here. I didn't like a song that was here. I didn't like a song that was here. And I didn't like a song that was there. So now we have our data. This is our information. It's very simple. But what if I were to give a new song? Let's say I was wondering, what about a song that had this volume, this tempo? Would I like the song? Well, to be honest, it's pretty easy. You can take a look at this. I'm probably going to dislike it. So why is that? Why did I make that decision? Obviously, it's because there's three other songs of very similar volume, very similar tempo that I disliked. So I'm probably going to dislike that song. So what we're looking for, in a sense, is the nearest neighbor. Now, let's say we found more information and it turned out that I actually did like the song. And what if we found out that I liked this song? Well, now if we have a song here, what do you think that's going to be? Now this is the hard sort of thing to figure out, because I receive neighbors. There's two songs that I do like. There's two songs that I didn't like. Where about this song is? And it kind of depends on what way you think about it. So in this case, let's say there's three songs that I didn't like. There's two songs that I did like, and we just draw a circle further and further, concentric circles around, and we hit three songs that I didn't like, and we decide to stop there. Now, this is actually an algorithm called k-nearest neighbors. And k, in this sense, is the amount of neighbors we need to reach before we decide whether or not we make a classification. So, in this case, k, in our first example, just needed to be 1. We just looked for the closest neighbor that was nearby the song. Now, in this example where I drew concentric circles until I stopped, I decided I was looking for the 3 closest neighbors which fit. So then at the k equaled 3. Now, how do we decide what k we're going to get? That's going to be a little bit more complicated.